This is the proof you did in your warm-up. We proved that triangle ABD was congruent to triangle CBD using side angle side, which means we used the sides AD and DC, the side BD to itself, and the two right angles are congruent. So if I look at this next question that's in your notes, how is this question different than the one that we just answered? So in the last question, we proved the triangles are congruent. If we look at this, the proof statement is different. The given statement is the same. So we're supposed to prove that segment DB bisects angle ABC. So what we're going to do with these proofs is we're going to add on to where we left off. So we used the fact that triangle ADB was congruent to triangle CDB by the side angle side congruence postulate. If we think back to how we started this chapter, with the triangles being congruent, we had 6 congruent parts. In our proof, we only used 3 of those congruent parts. We used 2 sides and 1 angle. So we used angle or side AD congruent to DC. We used segment BD congruent to itself. And we used angle 1 congruent to angle 2. Which means we actually have 3 other pairs of congruent parts. So by knowing the triangles are congruent, we know we have 6 pairs of congruent things. 3 pairs of congruent segments, 3 pairs of congruent angles. We've already used 3 of them to prove that the triangles were congruent, which means the other 3 pairs are also congruent. They're corresponding parts. So we're adding on to our proofs. And we're going to use what's called Cpctc. And what it means is the corresponding parts of the congruent triangles are also congruent. And it allows us to draw conclusions after we have congruent triangles. So we showed that triangle ABD was congruent to triangle CBD using side angle side. So our other congruent parts are also congruent. All 6 pairs of congruent pieces are congruent if we know the triangles are congruent. We used 3 pairs to prove they were congruent. The other 3 pairs of congruent parts are also congruent now that we know the triangles are congruent. If you prefer, you can also use the definition of congruent triangles instead of Cpctc if you want. Because the definition of congruent triangle says if 2 triangles are congruent, then all of the corresponding parts are also congruent. So let's take a look at a proof like this. So the first thing we have to do is prove our triangles are congruent. So if TR bisects angle STQ, and we are given that, angle STQ is up here, so I'm going to put numbers in those angles. That means that angle 1 is congruent to angle 2. And that's our definition for an angle bisector. We are given that angle S is congruent to angle Q, so there's our second piece. And that was given to us. So we can also use, we always need a side. So our side would be the shared part, segment RT to RT, using the reflexive property. So our triangles are congruent. Now this is a tricky part. In the past, all the other proofs, you were proving triangles are congruent, so the congruent statement was given to you. When you write your congruent statement, you have to match up the corresponding parts. So we have triangle STR, and angle S is congruent to angle Q, and then back to T, and then R. And according to what we have marked, that would be angle, angle, side. The side does not touch angle Q, so it's angle, angle, side, not angle, side, angle. All right, now we know all of our since our triangles are congruent, all 6 pairs of things are congruent. So our conclusion is going to be, after we show the triangles are congruent, SR and QR are one of those pairs of corresponding parts. So those segments are going to be congruent by Cpctc. So we've just added one step after we showed that the triangles are congruent. So what I want you to do is I want you to start by proving these 2 triangles are congruent in your notes, and then add on an additional step of Cpctc to say that BR is congruent to KT. So to get these triangles are congruent, we start with angle R and our angle T being right angles. That's given to us. And as I look at this, knowing that MB and MK are congruent, that's the hypotenuse of a right triangle. But in order to have that, we have to say we have right triangles. So anytime you're going to use hypotenuse leg, you need to say in your proof that you have 2 right triangles. So angle BRM and angle KTM are both right triangles. And that's what that blurry thing says, using the definition of a right triangle. Then you're also given that MB is congruent to MK, and that M is the midpoint of RT. So RM would be congruent to TM using the definition for a midpoint. And then your 2 triangles, make sure you match up your corresponding parts. Triangle BRM is congruent to triangle KTM using hypotenuse leg, because the hypotenuse is KM and BM, and you have a leg MT and MR. So now that our triangles are congruent, the other 3 pairs of parts that we haven't used are also congruent, which means we can now say that BR is congruent to KT using Cpctc. Corresponding parts of congruent triangles are congruent. And as we look at one like this, notice this time we're supposed to show that something bisects. So anytime that we're not using congruent parts afterwards, we're going to have 2 extra steps. So we're going to show that these triangles are congruent, and there's several ways that we can do this. But if we look at IE is parallel to GH, parallel lines give us congruent angles, back from chapter 3. So we're going to pick some congruent angles in there. So if IE is parallel to HG, make one of these your transversal. That means that we could say that angle I is congruent to angle G. And that would be, if we have parallel lines, then our alternate interior angles are congruent. So that gives us one part. We have these nice vertical angles in the middle. So I can say angle 1 is congruent to angle 2. And that's if we have vertical angles, then our angles are congruent. We are given that F is the midpoint of GI. So that's another given statement. Notice I'm listing mine separately because I'm using them separately. So find GI. So that would be this segment here. And if we bisect that, that means that IF would be congruent to GF using the definition for midpoint. So then I can say my triangles are congruent. And again, I have to make sure I get my corresponding parts matched up. So triangle IFE is congruent to triangle GFH. And that would be by angle side angle. And there are other ways to prove these two triangles are congruent, but the way I used is angle side angle, so that's what we're going to show. And, whoops. Now we're going to add on 2 more steps. So our corresponding parts for there, and if you think kind of backwards, if I want to say that GI bisects EH, I am going to need, if I kind of start from step 8 and go backwards, to bisect EH, I need EF to be congruent to HF, because that's what it means to bisect. So my Cpctc part can only be used for congruent parts. So my congruent parts would be EF and HF. And then, because those are congruent, we have bisected that segment. So that would be the definition of a segment bisector. And I apologize, my stylus is not writing very well on my screen. So the definition for a segment bisector. Alright, so just like on the one we did before, I want you to pause the video and I want you to prove the triangles are congruent, and then think about what do I need to know to have an isosceles triangle. And then you're going to add on 2 steps at the end, Cpctc, and then the definition for an isosceles triangle. So think about what you would need to do to show that. Alright, so this time we're going to prove the triangles are congruent by side angle side. So we've got perpendiculars, which give us right angles. Since we have right angles, angles 1 and 2 are congruent. We're bisecting segment DF. So DG is congruent to FG, which gives us our second congruent part. And then EG is congruent to itself using the reflexive property. That makes triangle DGE congruent to triangle FGE. I have to match up my corresponding parts. Alright, so if I want to show that triangle DEF is isosceles, I need 2 congruent sides. So my congruent sides, after I've proven my triangles are congruent, are going to be segment DE congruent to segment FE. And those are my congruent parts. So that's my Cpctc, or if you prefer, you can use the definition of congruent triangles. And then our last step after that, because we have 2 congruent sides, we can say triangle DEF is isosceles. And that is our definition for isosceles triangle. So remember, if you have a word after your congruent triangles, you're going to need 2 steps. 1 step to do the corresponding parts, and then 1 step to say whatever it is using the definition of whatever it is. So we want the definition of isosceles. Definition of isosceles says we have 2 congruent sides. So what are the 2 congruent sides? That's what your Cpctc is going to get you.